Okay, this is General Vision Booklet 9, Higher Tier Numeracy Style Questions, and this is a calculator paper, so make sure you use your calculators. So Jenny, question 1. Jenny, Mark and Karis are helping a charity organisation by putting leaflets in envelopes. They are each given the same number of leaflets. At the end of the day, Jenny has put 75% of her leaflets into envelopes. Mark has put 4/5 of his leaflets into envelopes. And Karis has put 0.7% of her leaflets into envelopes. Who has put the most leaflets into envelopes? You must show all your work and demonstrate how you decide your answer. You could do this a number of different ways. You could just convert them all to the same, so you could change them all to percentages. It's probably the best way. So see or you could pick a number, so pretend they've all been given 100 leaflets and see what amount they've all been given. I'm just probably going to put them all into percentages. So Jenny is already in percentages. So Jenny did 75%. Mark, he did 4/5. So 4/5 is the same as 8/10, which is the same as 80%. So he did a bit more. Another way to do that would be on your calculator, 4 divided by 5 and then times by 100. And Karis did 0.7. You should know how to change decimals and percentages, just times by 100, which is 70%. So we can see Mark did the most. Question 2. A piece of land is used as a car park. The shape of the dimensions of the land are shown below. So we've got trapezium. Calculate the area of the piece of land. So the area of a trapezium, this would be at the front of your booklet. This is like the first formula. It's the first one. So the equation of the area of a trapezium is a half times a plus b, then times our height. You don't normally have these times in it. It's normally they're attached, but don't forget they do mean times. It's normally written as half a plus b h. So don't forget there's times in there. This top left is a, this bottom left is b, and this is our height. So all we need to do is a half times 70 plus 100, and then times that by 40, and we get 3,400 meters squared. It's a very simple question. C is question 1, so that's going to be like a C grade question. I don't even feel like it's a C grade. That's very simple. I don't know how to pronounce that, was driving along a 10-mile stretch of road that has a speed limit of 40 miles per hour. The time was 14:50 as Dwight's car entered the speed limit zone. As he left the 10-mile zone, the time was 15:10. Calculate Dwight's average speed over this 10-mile journey. So speed is distance over time. So we've got our distance as 10 miles, and now we need our time. So from 14:50 to 15:10 is 20 minutes. Now, don't use 20 because then you'll have miles per minute. That's 20 minutes. Obviously, there's 60 minutes in an hour, so that's a third of an hour. So I would use a third instead of 20. So then I would do speed is going to be distance 10 divided by a third, which is going to be 30 miles per hour. Okay, because they've got theirs in miles per hour, don't use miles per minute. You're going to have 10 over 20, which is a half miles per minute, which doesn't make much sense. Well, you know that's half an hour really, so half, so 30, but I would change it to a third. So he could have driven faster if he wanted to. Could he have driven faster during his time explaining your answer? Yes, he could have. So he could have gone faster by 10. Make sure you write that sentence. Question 4. Would a cylindrical can of radius 5 centimetres and height of 14 be able to contain 1 litre of liquid? So we've got a cylindrical, so that means a cylinder. Radius of 5, so this length is 5, and our height is 14. A volume is going to be your area of a face, so pi, area of a circle, pi times the radius squared, and then times that by your height. So let's work that out. So we've got pi times 5 squared times 14. These are all going to be in centimetres, so we're going to have centimetres cubed as our answer, so that is going to be 1099.56 centimetres cubed. Now, will that contain 1 litre? You need to know that 1 litre is 1,000 centimeters cubed. Okay, very good conversion that you need to know. They always love putting that with cylinder questions. So yeah, I mean, it's only this, the cylinder can hold a little bit more, so you would be able to. So put a sentence like, yes, they'll be able to fill, they'll have 99.56 centimeters cubed space or something like that. Question 5. The members of a rock band think they can perform live on stage at two concerts, both held at the same date. The first concert is held in London and the second in New York. Use the following information to decide if it's possible. So they wanted London and New York in the same day. That's like a long flight. The time in London is 5 hours ahead of the time in New York. Both concerts start at 6 p.m. and end at 11 p.m. local time. The band will perform on stage for 20 minutes of each concert. Excuse me. The flight time between London and New York is 7 hours and 20 minutes. As it's a charity event, the two cities, airports and airlines have all guaranteed that the time from leaving the stage in London to the plane taking off will be 1 hour. The time between the plane landing and the band reaching the stage in New York will be 40 minutes. You must show all your workings and clearly explain how to decide whether it's possible or not possible. Okay, so the first concert is held in London. So we're going to start in London, and they start at 6 p.m. So I'm going to do like a London and New York timeline basically. So performance is 20 minutes. So in London, the performance ends at 6:20. Now that's 5 hours ahead of New York time. So in New York, take away 5, it's going to be 1:20 p.m. So let me put p.m. and a.m. just because otherwise I'll get confused. Then they've got to travel to the airport. And travel to the airport. At the time leaving the stage from London to time taken will be 1 hour. So that's an hour later, so plus 1 hour. So we got 7:20 p.m. plus an hour, 2:20 p.m. Then the time between, after we travel to the airport, we've got to take the plane, haven't we? So the plane is 7 hours 20 minutes. So we're plus in 7 hours 20 minutes, so that's going to be 2:40 in the morning. But London time, that's going to be 9:40 p.m. Then we've got to travel, plane landing and the plane reaching the stage in New York will be 40 minutes. So travel to New York stage or whatever, we've got 40 minutes. So 40 minutes on, so London time, that's going to be 3:20 in the morning and 10:20 p.m. or they make it, don't they? 20 minutes of the concert and it ends at 11 p.m. We've got loads of time. We've got 20 minutes spare. So the performance, look, that doesn't say performance. 20 minutes, so that's 3. Why have I put dots there? I've got 2 dots in my times. That's horrible. 3:40 a.m. and 10:40. They're going to be like the last act on, but okay, so yeah, this is possible. That I wouldn't do it, but so I would say we've got 20 minutes spare. Lovely. Question 6. Jamal was preparing for a trip to the United States of America and Mexico. He exchanged an equal amount of pounds to US dollars and for Mexican pesos? Don't know. So calculate on which of the two country exchange rate Jamal lost the most money. Okay, so £100 is obviously going to be $162. $162 back in, so converting it back. So use this one for this one. So if I convert it back, maybe I should write what I'm doing. Yeah, I'm going to start again. So if we're converting our money into their money, we times. If we're converting back, we divide. So if he had £100 and he was putting it into US dollars, we would times that by the 1.62 to get $162. So now he's in the US and he wants to exchange it back. So he's got $162, and we're using the second conversion because he's putting it back. They always do this. It's not the same exchange rate. They always change it. So we're dividing that by 1.84 to get £88.04. So he's lost. So we've got £100. Take away £80.04 is £11.96 lost. So that's the American one. Let's do Mexican. So £100, and we're doing 20.24 to start with. Obviously just timesing it by 100, so 2024 pesos. So we've got 2024 pesos. I don't know why I'm saying that weird. And we are putting it back, so we're dividing it by 22.45, and that gives me £90.16. So he's made a loss. 1916 made a loss of £9.84. So obviously he has more of a loss in the US. You could have kept them in pounds if you wanted to. £1 into 162, then 162 divided by £1.84. I just used 100 because I like working with bigger numbers than small decimals. Okay, an office manager records the number of photocopies made by his staff every day in September. The table below shows a summary of her results. So, grouped frequency table. Calculate an estimate for the mean number of photocopies per day in September. So, when we're doing an estimate for the mean, we need to use the midpoint in our frequencies. So we use the midpoint of all of these groups. Sorry if you can hear the dog barking in the background. So to find our midpoint, we just middle between 0 and 99. If you don't know how to do that, add them and half it, which is 49.5. This 149. You should see a pattern. 249.5, 349.5, 449.5. So once we've got our midpoint, because these four could be anywhere between 0 and 99, so we're just using the midpoint as kind of like an estimate. So now we need to times these together. So our midpoint times our frequency. So 49.5 times 4, I don't know why that was index, is 198. Second one, 149.5 times 9 is 1345.5. Next one you should have got 3493, 349.5 and 899. Next step is to add all those up. So 6285, and to calculate our mean is once we've added them up, we divide by our total frequency. Total frequency is this total here, or they've told you in the question, I think, haven't they? Days in September, so you should know there's 30 days in September. So it's 209.5. And okay, so the mean number of photocopies made per day in September is 209.5. Obviously you couldn't make 209.5 photocopies, like you can't make half a photocopier. So if you want to round that to 210, really, shouldn't we? Because you can't make half a photocopy. A complete following statement. My answer is only an estimate because I've assumed the midpoints, because from the groups. Because like I said earlier, these 4 days, they could have had 2 each day, or they could have had 97 each day. You don't know where that number actually lies, this grouped data, so we're using the midpoint. Describe a more accurate method for the office manager could use to calculate the mean number of photocopies per day in September. So if you use smaller groups, or no groups, but that would be like, smaller groups will give you a more accurate measure. Because obviously 0 to 99 photocopies, and one day they could just do 1 photocopy, the next day they could do 74 photocopies, and things, they go from 0 to 500, so it'll be a lot bigger, but the smaller your groups, the more accurate your answer will be. Okay, Bryn and Luke cut some branches off some trees. Okay. The group frequency diagram shows the diameter of the branches they cut. So we got who's at the top? Bryn and then Luke. Lovely. How many of the branches that Luke cut have diameters between 10 and 30? So we want this amount here. So we're just going to add both of those. So this one goes across to 30. So this one is 30 in here. And this one goes across smack bang in the middle again, 70. So 70 there. 30 and 70, 100. Simple. Who cut more branches with a greater diameter? Give reasons for your answer. It's definite. So this one is also 70. I'm just going to write actually the things in all of them. So that's 10, that's 30, and that's 40. That's 20, that is also 30. You can clearly see that it's Bryn because this is 70 and 40, that's 70 and 20. So he does 20 more. You could have just focused on the 30 to 40 gap if you wanted to. So you're going to say Bryn, but make sure you say like between 30 and 40 is more, for example. Calculate an estimate for the mean diameter of all the branches that Bryn has cut. They're very similar to the last question. This is going to be a group frequency table. So between 0 and 10, the frequency was 10. So 10, 30, 70, 40, 10, 30, 70, 40, 10, 30, 70, 40. And it goes 10 to 20, 20 to 30, 30 to 40. 0 to 10, 10, 10 to 20, 20 to 30, 30 to 40. I'm just making my own diagram, I'm making my own table, frequency table. So between 0 and 10, he had 10. So the first thing we do is we find the midpoint. I'm going to move this over. So the midpoint of this group from 0 to 10 is obviously halfway, 5. Middle between 10 and 20, 15. Middle between 20 and 30, 25 and 35. As soon as we've got our midpoint, we just times them. So 10 times 5, 50, 15, 30, 4, 50, 25, 7, 17, 1750, and 1400. Add those up, and we get 3650. As soon as you add them up, you divide by our total frequency. So our total frequency is going to be 150. Why have I got an equal sign there? So divided by 150, and we get 24.3 centimeters recurring. Now we don't have to round this one because centimeters can go to infinite, basically. Next one. The median diameter of the branches cut by Bryn lies in the group 20 to 30. Explain how this can be checked using the frequency diagrams. So the total is obviously going to be, they add up to 150, don't they? The median is going to be half of that, which is 75. So in here we've got 10, then we've got 30, that's 40, and then we've got 70, that's 110. 75 is definitely going to be like here somewhere. Okay, so it's definitely going to be in 20 to 30. So that's all you need to do. 75th person or tree or branch, wherever he's done, definitely lies in there. So you just total frequency halved, so we got 150 divided by 2 gives us 75, and the 75th lies in 20 to 30 group, because we got 10, then 30, then 70, so that's 110, which is less than in 75. 75's got to be in there. Okay, next one, question 9. A window cleaning company has been asked to clean the glass of 36 identical large greenhouses owned by a fruit farmer. On the first day, 5 cleaners, right, there's 5 cleaners, how long do they take? Clean the glass of 15, why does it do that? 15 greenhouses in 8 hours. Cleaning company wishes to complete the cleaning and remaining of the 21 greenhouses within 6 hours on the second day. I've done this in a previous video. So we've got our 5, we're going to times it by the fraction of 21 over 15 and times it by a fraction of 8 over 6. Okay, because it's a simpler way would be, you could do 5 cleaners, 15 greenhouses. So divide those to get how many cleaners it would take. 1 greenhouse, then you want to times that by the 8 hours. But then we got 21 greenhouses, so you times that by the 21 greenhouses and then divide by 6. This way is just a shortcut way, and you get 9.33 cleaners. Obviously you can't have 9.3 cleaners, so it's going to be 10. So 10 cleaners required. So you do your 2 fractions. So you do the one you don't know. Oh, why did that 15 just appear then? Look at that. So you just want times by 2 fractions. This one over this, then this over this. Okay, Thomas invests 5,720 in 2 years at 3% per annum compound interest. Find the compound interest earned in the 2 years. Give your answer correct to the nearest penny. Okay, so compound interest, we need to first find our multiplier. So they have 100% of their money. Interest means they're adding on, so it adds 3% each year. So that's 103%. As a decimal, 1.03. So our multiplier now. So we've got 5,720 times our multiplier to the power of how many years? 2. So we do it to the 2, which is 6068.348. We should do that to the nearest penny, really, shouldn't we? My bad. Find the compound interest earned. So do check your questions with these, because sometimes they just want to know how much they have at the end of the 2 years. Sometimes they want to know how much interest they've earned. So to find out how much interest they've earned, we just take our answer and take away our original, so 5,720, which leaves us with £348.35. Okay, Anne is standing on a horizontal distance of 150 metres away on the base of a vertical tower. As she views the top of the tower through a pair of binoculars, the angle of elevation for the top of the tower is 39. So this angle here is 39 degrees. Binoculars are held at 1.7, so this gap here is 1.7 metres. Got to do some algebra of my own. Calculate the vertical height of the tower, so we've got to calculate this length. So you firstly, because don't use the whole thing as a triangle, so you've got 1.7 metres here, you're going to use this triangle to find out this length here, x, and then just add 1.7 at the end. So that's the length we're going to find x. So first, step 1, label your sides. So because this is our opposite, we're going to label that O. Then this is A because it's next to our right angle, and our angle is adjacent to it, so we've got O and A. Next step is to choose your ratio, either saw, car, or tower. So O and A, don't label the other side, you don't need it. It doesn't have an X, it doesn't have a number next to it. So the only one it has is tower, so that is tan of the angle is O over A. So I chose my ratio. Next step is to substitute my numbers in. So tan of the angle, do I have the angle? Yes, 39 degrees. Is O, do I have O? No. Is X. Over A, do I have A? Yes, 150, because our length is obviously going to be the same as 150. Next step is to solve. So when X is on top, we need to times. So we're going to take 150 and we're going to times it by tan of 36. So I always do the number first because you're either times in or divided. So if X is on top, you times. If X is on bottom, you divide. If X is next to tan, then you're going to shift. So when you do 150 times tan of 39, you get 121.47 meters. Don't forget you've got to add your 1.7, because that's how tall the binoculars are to find the height of the tower. So it's 123.17 meters tall. So step 1, label O, A, and H, but only label 2, because otherwise you'll get confused with step 2, which is choosing your ratio, either so, car, or tower. Step 3 is to substitute into that ratio, so substitute into so, car, or tower. Step 4 is to solve. And then obviously we had an extra step, which was to add 1.7. Okay, question 12. At an average speed of 80 kilometers per hour, it would take approximately 90 years to travel over the entire road network of the world. Use this information to calculate approximate length of the road network world in kilometers. Give your answer in standard form, correct 2 significant figures. So they've given us a speed and they've given us a time. They want us to calculate a distance. So we're going to use speed, distance, time. So speed is distance over time. Okay? So we've got our speed is 80. We don't have our distance, do we? No. But we have 90 years. I'm going to put years because obviously the 80 is in kilometers per hour. If there are 24 hours in a day, now you could do this a little bit differently. I'm going to put it into years and ignore the fact that we got leap years. You could probably put it into weeks is probably best, and that won't incur leap years. So you might get a little bit of a different answer, but when you simplify it at the end, we get the same answer. So 24 hours in a day, that's 365 days in a year. So that times those two, you get 8760 hours in a year. And because it's 90 years, I'm going to times that by 90 to get 788,400 hours. So instead of 90 here, I'm going to replace that by the hours. So I've got 80 over the distance is 788,400. Oh, so 788,400. So I'm just going to put a little note here. Ignore leap years, because obviously it's 364 days. 366 days. Yeah, it adds a day, doesn't it? So yeah, 366. It would probably be easier if I put it into weeks. So if you did 20, because 52 weeks does count years, really, doesn't it? The leap years, but you get the same answer at the end. So to find out our distance now, it's on top, so we've got times. So to find out our distance, we're going to do 788,400 times 80, and you get 6307200 kilometers. So 63,072,000 kilometers. Putting that into standard form, 6.3072 times 10 to the power 1, 2, 3, 4, 5, 6, 7. But they want it to go two significant figures, couldn't say that then, which is 6.3 times 10 to the power 7. If you used weeks, this is where you'd get your same answer. Okay, question 13. Rachel and O'Leary both ran in a marathon race. Rachel completed the race in 2 hours 54 minutes, measured correct to the nearest minute. O'Leary completed the race in 3 hours and 7 minutes, correct to the nearest minute. What was the maximum possible distance between their race? So Rachel, what did Rachel and O'Leary do? Their maximum and minimum, and then I'll show you which one you should use. You should only need Rachel's minimum and O'Leary's maximum. So Rachel's maximum, obviously, is correct to the nearest minute. So to do upper lower bounds, you half what it's nearest to. So nearest minute is obviously 0.5. And then you add it on and take it away for the maximum minimum. So Rachel's max is 2 hours and 54 added on 0.5 minutes. And her minimum is 2 hours and take it away, so 53.5 minutes. O'Leary, her maximum, so again correct to the nearest minute, so half of that, and then add on, take it away. So her max is going to be 3 hours 7.5 minutes, and her minimum is 3 hours and 6.5 minutes. So to calculate the maximum possible difference between their race, if she had the lowest time, she had her highest time, that's obviously a difference with 14 minutes. You can play around, but 14 is going to be your biggest answer. You want to do one, take away the other one. So 14 is going to be your biggest. The length of a side of a square piece of land is measured correct to the nearest meter. The largest possible area of the land is calculated as 756.25 meters squared. What is the possible area of this land? Okay, so we've got a square, which is the area is 756.25. Luckily it's a square, so to find a length we would just square root that. So when we square root it, square root of 756.25 gives us 27.5. So because obviously they told us that the largest possible area was 27.5, so that length is the maximum correct to the nearest meter. So when they did it correct to the nearest meter, half a meter is obviously 0.5, and then they added it on. Okay, so the original, or what they said, it would just be 27. So because they added it on, that 0.7 is 27.5. So to do their minimum, we would take it away, so it's 26.5. So all you need to do to calculate the least possible area is 26.5 squared, or 26.5 times 26.5. So the least area is going to be 26.5 squared. So 26.5 squared is 702.25 meters squared. Okay, a child's wooden toy is made up of solid hemispheres symmetrically attached to one face of a solid cube as shown below. The radius of the circle's face of the hemisphere is r centimeters. The diameter of the circular face has the same length as the side of the cube. Okay, yeah, so it fits on it like perfectly. The volume of the whole toy is 1,261.8 centimeters cubed. Find the height of D of the toy. Okay, so you're going to need two things basically. You need to know the area, we need to know the volume of the cube. So obviously it's got a length of the diameter of the circle's face has the same length of the side of the cube. So this is obviously going to be 2r, isn't it? Because that's r there as well. So the volume of the cube is going to be 2r cubed, really. So the volume of the cube is obviously going to be the length cubed. Volume of a sphere, well, hemisphere, because it's not a full sphere, is it? Volume of a normal sphere is 4/3 pi r cubed. That's given to you in a formula booklet, but quick Google. And then we obviously hemisphere, so we want half of that. Right, so let's do volume of our cube first. So volume of cube. So like I've drawn on the shape, the length is 2r. So all these lengths here are 2r. So the volume is going to be 2r cubed. So don't forget to cube your 2 here. So 2 cubed is 8. So it's going to be 8r cubed. So that's the volume of the cube. Don't forget to cube your 2. So volume of sphere is going to be 4/3 pi times the radius cubed, and then half of it. So that's literally just the formula. And then they're combined, that's it, isn't it? Yep, and their combined volume, so 8r cubed plus 4/3 pi r cubed halved is 1261.8. I feel like we've done a similar one in this in a different booklet. So you could do a number of different things here. You could do 8 and 4/3 and then half it, or you could take out r cubed and then divide by everything. I think I might just do that. I could take out r cubed, so I'm going to factorise out r cubed, and I'd be left with 8 plus 4/3 times pi times a half. You could work that out. Let's work that out. So we got, I'm going to do the 4/3 times pi times a half. That gives us 2/3 pi plus 8 gives us 10 point something something something. So we got r cubed times 10.09 blah 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 is 1261.8. Then we just divide that. So r cubed is 1261.8. I'm just going to keep it in my calculator so I'm more accurate. Or 125 0.00000606. So I'm just going to do 1.25. So to find r, we're going to cube root it. You should know what the cube root of 125 is. It's just 5. It's 5 times 5 times 5. Calculate the height d of the toy. Okay, so d is just going to be 2r. Add another r, isn't it? So d is 3r. So 3 lots of 5 is 15. So d equals 15 centimeters. Okay, question 15. An empty tank is used to... Oh, this is velocity time graph, isn't it? Lovely. An empty tank is used to fill with water. Graph below shows the rate of flow, blah, blah, blah. Controlled fill it in the tank. After 5 minutes, tank's full. Lovely. Estimate the volume of water in the tank. So when we... I mean, it's like travelled time, distance. You just got to do the area under the graph, basically. But it's told us to use T0, T1, T2, T3, T4, T5. So we're going to split that up and calculate the area. So I'm going to draw my lines first. So at T1, I'm not in a ruler. At T1, we normally have a triangle at the start and the end of these things. Sometimes not at the end, but it doesn't matter. We just split it up into triangles and trapeziums. And there is an estimate, don't forget. Obviously, it's like you can see that some bits, it's going to be more of an underestimate. But that doesn't matter. So we've got 1, 2, 3, 4, 5 shapes. A, B, C. Oops, I'm still on my ruler, aren't I? A, B, C, D, and E. So all you've got to do is find the area of each of those shapes. So I'm going to start with A. A is an area of the triangle. So it's a half times the base, which is 1. So it goes across here 1 times this height here. So it goes up to... I think it goes up to the second one. Each one is 2. 2, 4, 6, 8. Yeah, so each one is 2. So that's 52, which is 26. Right, to do B, it's a trapezium but slanted. Okay, oh, well, not slanted, but it's a trapezium just turned around. So in your formula booklet, you'd have a trapezium like this, and this would be A, this would be B, this would be H. And they would say it's a half A plus B times height. Just turn it so it's like this now instead, or well, actually it's the other way, isn't it? So it's like this instead. So this is A, this is B, this is our height. So it's still half A plus B times height. So we're going to do a half times these two lengths. So we got 52 from the previous one, plus, what does that go up to? 54, 55. And we want to times that by the height, which again is 1. So we got 53.5, so that's 1 there. So for C, we want this one and this one. So we got half times 55 from the previous one, plus, what does that go across there? 46, 2, 4, 6, yeah, that's 46 there. And then again, that height there is 1, so that gives me 50.5. Now we're doing D. So again, a half times these two lengths, this one and this one. So 46 and just under, so 29. And again, height 1 gives me 37.5. Last shape, E, triangle. Half base times height. Base is 1. Height was 29 from the previous one, which is just half 29. 14.5. Add all those up, and I get 182. Where is this? Liters per minute squared. Okay, liters per minute squared. So we got liters per minute here, but obviously we're timesing it by another minute. So it's liters per minute squared. So 182 liters per minute squared. Oh, I squeezed all that in and there's last space there. Question 16. A building society is advertising the following savings rate. Oh, we haven't had any PR question in all these booklets. AER, sorry. The formula that you don't, it's not normally here. So this is from an old paper. It's from 2010. No, 2014, Jesus. So don't use that, because I haven't taught you that way. If you look back in your books, those who have your books, you should have the AER formula. If you quick Google it, you might see this one. You can use that one if you want, but it's not the way I've taught you. So the way I've taught you is the AER, because this is what's in the current formula booklets, is 1 plus I over n to the power of n minus 1, where I, let me write this down, where I is the nominal percentage in a decimal, and n is the number of compound years. Compounds, you know, how many times it happens per year that you get it. So for this one, I is going to be 6% decimal, 0.06. N is going to be every 4 months. So how many times does that happen in a year? How many 4 months are in a year? So 12 months divided by 4 is 3. Just going to put that into your formula, so my formula, which is 1 plus, that's a t, 1 plus 0.06 over 3 to the power of 3, take away 1. So we've got 0.0612. They want an AER. An AER is a percentage. That's why you can see on here it's actually a little bit nicer, but they've times it by 100 at the end. So you want that as a percentage, which is 6.12%. So when they say 2 decimal places, they mean your percentage. AER is a percentage. So it's 6.12%. Okay, we're not doing another velocity time graph, surely. Oh, okay. A car travels 2 sets of traffic lights, time 0, velocity time there. Ah, we're doing acceleration, lovely. So calculate an estimate of the acceleration when the car is t20. So t20, acceleration is where you find the gradient of the line. Now obviously that's not a line, that's a curve right there. So you draw a tangent to your curve as accurate as possible. So I make it nice and long so I can choose nice straight, nice points. Okay, oh, I'm just going to move that over a little bit. So that, see, it's touching the graph, nice tangent to the line. Now you just want to find the gradient of that line. So a gradient, let me put it here, gradient is your change in your y coordinates. So you pick 2 points. Top fraction change in your y, bottom is your change in your x. So pick 2 points. Now I like to pick points that are nice on the x-axis or the y-axis. So you see how this one is in, these 2 points are in nice places. If you picked these 2 points, it would be fine. But I like to pick easier, just one set of easier ones anyway. So I'm going to read across for my y's first. So let's read across. That's on 25, on 27 and a half really. Oh, I'm just going to put 27. My thing is probably a little, yeah, it is a little bit dark. So if I read across here, each one is 1, isn't it? So that's 19, each 2, sorry. And then I read down and those is 30 and 20. See how those 2 are easier. So my gradient, change in y, so we've got from 27 to 19, it's a change, no negative numbers. You can see it's going up anyway, so the gradient is positive. It's not de-accelerating, it's accelerating. And then 30 to 10, put that in a calculator, we've got 0.4 meters per second. So the accelerating is 0.4 meters per second. Please don't say it's the next page where I do. Calculate an estimate for the area of the curve. I just did this. Time axis and the line T30. Oh, we only have to do 0, 10, 30, 20 and 30. Oh, I bet the bottom one is all of them, isn't it? Calculate for the average speed of the car is 60 seconds. Why split? Why split it up? Why just do it all? Okay, so we've got to split it up in 10, 20 and 30 for the first one. So it doesn't matter, it doesn't care of the ones after 30. So for the first one we just got these 4 here. So we've got a triangle, trapezium. Hopefully you remember this from earlier. A, B, C. Later on it wants you to do the other ones. So for A, I'm not going back and forth, I'm just going to write them down. So A, you can look, is going to be a half. Ooh, why is it? Oh, I'm still in my thing. There's a half times the base 10 times the height. I read that as 17 of 85 for B, and then C. So for B, you've got a half trapezium, so top, which was 17. Add, I read that across as 23, times by the height, which is 10, got 200. And for C, a half times 23 plus 25, so it's just two heights of the side ones, times 10, which is 240. Add them all up, we get 525. Is it meters per second squared? I hope so. Meters per second, yeah. Okay, an average speed of the whole thing. So we've got A, B, and C. We just need the other two. So I'm gonna. Oh look, it's just a rectangle and a triangle. Look how nice that is. Ruler. So we've got this one here. I'm gonna call that D. I'm gonna call that E. So we've just got a triangle and a rectangle. So we've got D and E. Why did I just do that? I'm still in my ruler. So D was going to be just rectangle 10 times 25, which is 250. And then E is going to be a half base. That doesn't look like a half, but 20 times 25, which is 250 again. It's 500. They want the total, so don't forget to add this one. So 500 and 525 is 1025 meters per second squared. Excellent.